Hello and welcome back, everyone. Today we're going to be looking at transforming functions. We're going to be making a rule sheet today, seeing how functions change based on what you modify to the function notation. So today we're going to be looking at this M-shaped function. It doesn't really have a proper name, so we're just going to call it f of x. So the first rule, or the first thing we're going to change with this function, is what happens to our graph if I add or subtract a number on the outside. So for example, if I put a +1 on your screen, this red function is the original. The black function is where it moved to. So what is happening is I add a number on the outside. What do you think is happening? How is it moving from the red to the black? Okay, similarly, let's look at if I subtract a number on the outside. So how is the red function moving to the black? What do you notice is happening? All right, and maybe to help you see it a little bit more smoothly, I added a little slider here, like if we have a plus k. So I slide this to the left, it's going to be a negative. So this would be if I'm subtracting. So notice as I subtract, it moves down. And then go back to 0. And then when I go to the right, it's like a positive. So it'd be like I'm adding on the outside. Notice when I add a number, it slides up. So basically your k value slides it up or down based on the sign. So on your transformation rule sheet, I want you to copy what I have in this first row. A plus on the outside moves your graph up. A minus on the outside moves your graph down. This is called a vertical translation. If you remember back in geometry, when you translated points or on a graph, basically you slide them around. So add in a number slides your graph up or down, or your function up and down. So I'll pause the video here for a sec so you can get this first row copied. Then we'll go to our next rule. All right, so back to our function. The next rule we're going to look at is if I add or subtract something inside my parentheses. So let's kind of see what happens. So when I add 1, add 2, add 3, add 4, add 5, how is the red graph moving to the black graph? And then let's look if we subtract. -1, -2, -3, -4, -5. And maybe just to show you with a slider really quick. So notice as I go to the left, that's as if I'm subtracting. So when I subtract, look at how it slides. Okay, and then back to 0. Notice when I go to the right, I'm adding. So notice when I add, which direction does it go? So what is happening based on whether I add or subtract? See if you notice what happened there. All right, so back to our rule sheet if you want to start writing this down, but you should have noticed when you subtract on the inside, it actually moves to the right. And when you add on the inside, it actually moves to the left. How I keep this straight is it's actually the opposite of what you would expect, because most students, if I asked you if you subtract, you would probably say it goes to the left. And if I said it adds, you probably say it goes to the right, but it is backwards. One kind of tip, if you see something on the inside of a function being modified, usually it's the opposite of what you would expect. So just be careful. And we represent this with an H. So a -H goes to the right, a +H actually goes to the left. So be careful about that. That's like an easy thing to mix up because it's kind of counterintuitive in my opinion. All right, so the third rule we're going to look at is what if I put a negative sign in front? So let's just see if I put a negative in front, how does the red function move to the black function? Do you remember what this is called? So if you remember from geometry, this is called a reflection, and more specifically, it reflected over the x-axis. Basically, every point flips over. So for example, an easy way to do this, if you are doing this by hand, see this point's up 2, now it's down 2. This point was up 1, now it's down 1. Basically, whatever the y value is, or how high or up it is, or how low it is, you flip to the other side of the x-axis. All right, so if you want to take a second and write down this third row. So a negative in front of your function just means it reflects or it flips over. And the proper name of that rule is it's called a reflection over the x-axis. Okay, and I'll give you a second to write this down, and then we'll do our final rule. All right, back to our original function. The last rule we're going to look at is if I put a number in front that I'm multiplying my function by. This one can be a little bit tougher to see because there's some different things that can happen. So let's say, for example, I just put a 2 in front. Let's say I put a 3 in front. 4 might be hard to see, but notice what's happening here. Any ideas maybe how this graph is changing? You should notice when you put a number in front, it stretches your graph out. Like notice, for example, see how this point's at -2, this point stretches to -2, Basically, if you put a 2 in front here or 2 times your function, it multiplies all your y values by 2. So it's called a stretch when you have a number. For example, if I put in a 3, let me zoom out a little bit. But this point was at -2. Now the y value is 6. Basically, you multiply the y values, but basically the height gets tripled if you put a 3 in front. The next thing we're going to look at, though, is what if I put a fraction in front? So, for example, let me zoom back in. If I put a 1/2 in front. See how it kind of squishes down? Let's say I did 1/3, even squished more down, 1/4, 1/5, 1/6. So notice when you put a fraction in front, it's like it's called a shrink, or it compresses, basically it pushes itself down. So for example, if I put a 1/2 on the inside, basically it cuts your y values in half. See, this point was at -2,2. Now it's at -2,1. So if you put a number that's multiplied in front, it either stretches your graph, or we say it compresses, basically it pushes it down. So let's look at our rule sheet. But this is probably the trickiest rule because it depends on what number you have. But basically, if you see a number multiplied in front, that's going to change the y values of your function. Basically, it's going to stretch it out or shrink it down. All right, so if you want to write in this final row, basically, if your a value is bigger than 1, so like 2, 3, 4, 5, 6, it stretches and you can just multiply your y values, and that's called a vertical stretch. If your a value is a fraction between 0 and 1, so like 1/2, 1/3, 1/4, 1/5, 1/6, you basically divide your y values. So if it's like 1/2, you would divide your y values by 2. If it's 1/3, you divide your y values by 3. And that's called a vertical compression. I don't know if you know what the word compression means, but for example, if you're putting compressed air into a tire, basically you're putting a lot in a shorter space. So when your graph compresses, it's like kind of pushing it down. You're kind of shrinking it in a smaller space, the same function. So these are our rule sheets. You're going to see a delta mass section today where you're going to try and modify and apply these rules. So I'm going to cut and I'm going to just show you an example of that really quick. All right, so just to show you an example of what your delta math will look like today, they're going to give you a function. You're going to modify your function to move this black function to this dotted line. So you're going to kind of mess with these different rules we talked about today to see how it's going to work. So the first thing I notice, this first option is you can either make it a negative or a positive in front. So notice if your graph reflects, like I don't know if you noticed this is called a parabola, but it flips over. So I want to change that to a negative, and you're going to see it flips my graph. Now I kind of want to move my graph to the left, and I want to move it down. If you look at your rule sheet, to move it to the left, you actually put a plus on the inside. So for example, I can either count. For example, if I look at this point here, it needs to go over 1, 2, 3, 4, 5, or you can kind of mess with it. Let's try that 5. See how it kind of lines up. But if not, you can kind of modify it. Like if I did 4, I could see, oh, it needs to slide a little bit more. But now it's kind of this point's lined up with this. So I just need to move it down. So to move it down, I put a minus. So I would do negative, and I can count, it goes down 1, 2, 3, 4. But you can kind of guess and check, kind of modify these. But once your graph lines up, it'll say that is correct. And then you just press submit. But it will let you, I mean, you keep messing with it until you get the right answer. But kind of use those rules, but ask questions, but have that rule sheet handy. That's going to help you as we're doing different things with these transformation rules.